Welcome to electronics. My name is Professor Mtama. Today we are going to talk about extrinsic semiconductors. There are two types of extrinsic semiconductors. There is N-type semiconductor and a P-type semiconductor. First of all, let us talk about N-type semiconductor. An N-type semiconductor is formed when a pure semiconductor is doped with beta-valent elements. Beta-valent elements are group 5 elements. These are elements with 5 electrons in the outermost energy level, or we call them valency electrons. It has 5 valency electrons. That's 5 electrons in the outermost energy level. So when it is bonding with pure semiconductor, like silicon or germanium, that has 4, they only form 4 covalent bonds. They only form 4 covalent bonds, leaving one extra electron from the beta-valent that has 5 to be free. And this is the reason why these free electrons, they become majority. When they become majority, that's why N-type, we regard it having electrons as majority charge carriers, while holes as minority charge carriers that are thermally generated. So things that we need to know about N-type. N-type is formed when doped with group 5 or beta-valent elements. And the beta-valent has only 5 electrons, but silicon, which has silicon or germanium or the semiconductor has only 4, they only form 4 covalent bonds, leaving one or the extra 5th electron to be free. And that's why the N-type has electrons as majority charge carriers, while holes are minority charge carriers that are thermally generated. So when you are drawing the diagram, this is the diagram. You must know that silicon, the pentavalent, let us take for example phosphorus, it has 1, 2, 3, 4, 5 electrons. When they are bonding with silicon, they will bond with this. The first electron, then the silicon will bond here, then silicon will bond here, then the silicon will bond here. This one will be 1, 2, 3, 4, because silicon has 4. But the 5th electron will not be bonding, so it will be free. And this free electron is donated. And that's why we say that a beta-valent is a donor impurity, because it donates 1 free electrons. And that free electrons, because it gets excess electrons, depend the N-type has electrons as majority charge carriers. When it comes to P-type, P-type, it is a pure semiconductor doped by trivalent atoms. Trivalent are group 3 they are group 3 elements. So group 3, there has only 3 valence electrons. For example, aluminium or boron. So it only allows 3 covalent bonds. When they allow 3 covalent bonds, it means there will exist a vacancy or a hole where the silicon or germanium will not bond. And when there exists a hole, this hole have to accept free electron from the neighborhood or any roaming electron. That's why this is the reason why trivalent are called acceptor impurity, because they have a vacancy or a hole where they accept electron, so they are called acceptor impurity. So in P-type, you should know that holes are majority charge carriers, while electrons are minority charge carriers. When you are drawing the diagram, for example, using boron, you must know that it has 3 valence electrons, 3 valency electrons. So when they are bonded with silicon, the first electron will bond this one, the second will bond with this one, then the third will bond with that. But the fourth silicon, if it's trying to bond, there will be a hole here, because boron can only have 3 to bond with. So this hole that is created, which becomes excess hole, we say now the trivalent are called acceptor because this hole have to accept an electron. So the trivalent has to be called acceptor impurity. And you should also note that the p-type, the holes are the majority charge carriers while the electrons are the minority charge carriers. In summary, something that you should know the difference between p-type and n-type. You should know that n-type is doped with the pentavalent element, while p-type is doped with trivalent. Or another student can say n-type is doped with group 5 element, while p-type is doped with group 3 element. You must know that another difference, n-type electrons are majority charge carriers, while holes are minority charge carriers. When it comes to p-type, holes are majority charge carriers, while electrons are minority charge carriers. And we have explained how they are formed. That you must know here it is doped by trivalent, where a vacancy or a hole is created, so it should accept an electron, while here it is doped by pentavalent that creates an extra electron that is not bonded, therefore electrons becomes majority charge carriers, and therefore here the impurity is called donor impurity, while here the impurity that is doped with is called acceptor impurity. Thank you.